If you're interested in something so far out in the universe that you'll never see it, how do you go about it? A telescope is launched into space. Space agency NASA has done this by sending the James Webb Space Telescope into space. One of the places the space telescope will look is the very edge of the universe. The findings at the horizon of the universe are likely to be terrifying. If we build the first telescope, what will we see when we look out at the very edge of the universe? What are the repercussions for you? In this episode, we'll delve into the shocking discovery made by the James Webb Space Telescope near the edge of the cosmos and see how it affects everything. Since the dawn of time, humans have been curious about the ground beneath them, and as research technology has improved, that curiosity has expanded to embrace outer space. Although the idea behind telescopes has been around since the late 16th century, the first telescopes weren't created until 1608 in the Netherlands, and their discovery was crucial to our progress in astronomy. As the story of Galileo and his telescopic observations shows, a strong tool for viewing and collecting information can drastically alter one's perspective of the cosmos. Only a few astronomers at the time, including Galileo Galilei, pointed their telescopes skyward. Most early telescopes were employed for terrestrial observations and aiding operations like surveying and military tactics. After learning about the Danish perspective glass in 1609, Galileo was inspired to build his own telescope. His success in exhibiting the instrument earned him a lectureship at the university that would last the rest of his life. Galileo spent a lot of time perfecting his telescope. The first one he made could magnify objects by a factor of 3, making them look 3 times larger than they were. Later versions of his telescope could magnify by a factor of 8 and eventually by a factor of 30. Telescopes and outer space are inseparable. This is because space is so enormous. Proxima Centauri, the nearest star to Earth, is located at a distance of around 4.2 light-years. 1 light-year is about 5.88 trillion miles or 9.6 trillion kilometers. That's an incredible 25 trillion kilometers between Earth and Proxima Centauri. Although Elon Musk's colonization effort on Mars is quite close to Earth, volunteers will have to travel for months to reach the red planet and set up permanent residence. Telescopes are used when the distance is great enough. The incredible ability of magnification has allowed us to explore these heavenly bodies in greater detail. These telescopes see into space from their perches on bodies in orbit, such as the Sun or the Earth. Hubble is one such telescope, and it has been returning breathtaking photos of the cosmos for many years. However, a more capable and sophisticated eye has been implanted in space, and it will help us learn about the universe's outskirts. The James Webb Space Telescope, JWST, is shown here. Even though Galileo probably wouldn't approve of a telescope factory employing people from all over the world and spending millions of dollars each year on research and development, proponents insist the investment is worthwhile. The James Webb Space Telescope, JWST, will be the most important observatory for the foreseeable future, and thousands of astronomers from all around the world will use it during the next decade. From the initial flash of light following the Big Bang through the creation of solar systems that may support life on planets like Earth and the growth of our own solar system, every stage in the history of our universe will be scrutinized. All of the detectors in the telescope's cameras and spectrometers are sensitive enough to record extremely weak signals. The Near-Infrared Spectrograph, NIR-SPEC, is a single device that can observe up to 100 objects concurrently thanks to its microshutters, which may be set to different configurations. Webb also includes a cryocooler, which is used to bring the temperature of the mid-infrared detectors in another instrument down to an effective 7 Kelvin. Exactly how do we determine the existence of anything outside our observable universe? For instance, we may infer that the universe is spatially flat on the largest scales and is neither positively nor negatively curved to an accuracy of 0.25% based on our observations and the known fundamental principles that govern our observable universe. If the laws of physics as we know them hold, we can put a cap on the size of the universe before it begins to fold in on itself. The finest data for our extrapolation comes from the Sloan Digital Sky Survey and the Planck satellite. If the universe does eventually collapse in on itself, the visible portion we see must be at least 250 times larger than the observable region's radius, as suggested by the two sources. This means that the unobservable universe has a diameter of at least 23 trillion light-years and a volume of space that is more than 15 million times greater than the volume we can observe, presuming no topological abnormalities. That said, there are considerations that suggest the unobservable cosmos should be far larger. Can you name the farthest object in the sky that the human eye can detect? For one, there are astronomical features that we likely may never get a chance to observe in our lifetimes. Why? The current location of the cosmic event horizon is around 16 billion light-years from Earth. Is the finish line in sight? To put it bluntly, not anytime soon. If light were to start traveling to us now from this far away, it would take this long to get here. As a result, the expansion of spacetime is faster than the speed of light. Beyond 16 billion light-years, the cosmos is expanding faster than light can travel. Hence, light will never reach us. For the same reason, nothing that happens today outside the cosmic event horizon will ever be visible to us. However, modern telescopes like the James Webb Space Telescope, JWST, allow us to peer much further. The GNZ11 galaxy, located around 32 billion light-years from Earth, is the farthest known galaxy. Please be aware that this distance is determined after taking into account the accelerating expansion of the universe. The so-called surface of last scattering occurs roughly 46 billion light-years from Earth. This is what you will see no matter which way you turn your head. The surface of final scattering, after recombination and photon decoupling, resembles a homogeneous sphere of fog from which the first photons of cosmic microwave background radiation emanated. It is the source of the earliest light scattering, but the last of what we can observe, which is ironic, given its name. This is the end of the observable universe, or the farthest point in space and time that humans are capable of observing. Everything beyond this is considered part of the opaque universe. For now, this is the horizon of our visual perceptions, but not of our imaginative capacities. Proceed now beyond the known universe. I don't know what might live here. Only the past conditions at a single location in space have been examined. What may possibly exist there is an even more unbelievable mystery. The particle horizon is the farthest point into the past that can be seen, and it coincides with the edge of the observable universe. This poses the question, is this cosmos infinite? Since all of our observations have been made with Earth as the focal point and with the assumption that time moves backward within increasing distance, considering that Einstein's theory of relativity states that an infinitely flat universe must exist, we can safely assume that the cosmos has no boundary or limit. However, it is still unclear whether or not the cosmos is infinite. How so? While the hot Big Bang may mark the beginning of the observable universe, it does not mark the beginning of space and time. Because before the Big Bang, the universe experienced a period of cosmic inflation, during which it was filled with energy intrinsic to space itself, expanding at a constant exponential rate and developing new space so rapidly that the smallest physical length would be stretched to the size of the currently observable universe every 10 raised to the power of -32 seconds. While local inflation has stopped, there are still three major issues that have a bearing on the total volume of our universe. These issues revolve around the question of whether or not the cosmos has an upper limit. First, how vast was the portion of the cosmos that saw post-inflationary growth and yielded our hot Big Bang? Second, is it true that the universe will continue to expand forever? According to the theory of perpetual inflation, the duration of inflation prior to its termination, which led to the hot Big Bang, is the third question. Evidence for an edge to where inflation took place may appear in a year, and we may have to readjust our view of the universe once again. It's also plausible that several parallel worlds exist, each with its own set of physical cosmic structures and its own set of physical laws and physics. With this, the possibility of complicated life on one of the countless worlds in the universe becomes more appealing. There should be an exponentially large number of bubbles, each of finite size and scale, imprisoned within the large inflating spacetime. In such a case, what does the horizon of the universe look like? Even though you may have heard of flat earthers and thought they were crazy, it's possible they could be right if they extended their flat surface idea to the entire universe, not just the Earth. If you're having a hard time picturing the universe as a flat landscape, take heart. According to Einstein's theory of general relativity, the speed of light is unaffected by the warping of spacetime caused by massive objects like stars and black holes. It's the most natural explanation, given that the entire observable universe is contained within an event horizon, a boundary beyond which no light can travel and is expanding at a rate much greater than the speed of light, similarly to a black hole's event horizon but in reverse. The particle horizon defines the edge of the cosmos. It's important to remember, though, that the cosmos doesn't end where you might expect it to. How might you imagine that if you reached the edge of the universe, you'd be able to turn around and see a zoomed-out view of everything, including every galaxy, planet, star, etc.? However, this is probably not the best way to think about it, at least not in terms of space, as there would still be more universe even if you caught up with the edge. The idea posits that there is no way to get around this difficulty by thinking of the universe as a thing or a vantage point. Picture being outside of space and time, able to grasp the entire cosmos in your hands. Because the cosmos is self-contained, humans will never actually become aware of a beyond, at least not without interstellar travel. This means that the universe is probably spherical and maintains its size in your hands as its components move around. As humans continue to explore the cosmos, we remain limited by the constraints of both time and space. While the James Webb Space Telescope, JWST, can capture images and data from parts of the universe that are far beyond our reach, it also faces inherent limitations in our ability to truly understand everything that lies beyond our observable universe. The JWST is an incredible achievement, capable of peering deep into the past, observing galaxies as they appeared billions of years ago, and offering a glimpse of the universe's earliest moments. However, even with all its advanced technology, there are aspects of the universe that will remain forever out of our grasp. The vast distances, the expansion of the universe, and the speed of light create barriers that even the most sophisticated instruments cannot overcome. One of the fundamental challenges in exploring the cosmos is the nature of the universe's expansion. Since the Big Bang, space itself has been stretching, causing galaxies to move away from us at an ever-increasing speed. This expansion is not only happening in all directions but is also accelerating, meaning that regions of the universe are moving away from each other faster than the speed of light. This is a key reason why the observable universe has a limit. Beyond a certain distance, objects are receding from us faster than light can travel toward us, making it impossible for us to observe them. Even if a spacecraft were to travel at close to the speed of light, it would still never reach these distant objects because the space between us and them is expanding too quickly. In addition to the expansion of space, there are other factors that make our understanding of the universe so challenging. One of these is the concept of dark energy, a mysterious force that is driving the accelerated expansion of the universe. Despite being responsible for most of the universe's expansion, dark energy remains largely unknown to scientists. While we can observe its effects, we do not yet have a clear understanding of its properties or its ultimate role in the universe's evolution. This is just one of the many unknowns that continue to fuel scientific curiosity and exploration. Furthermore, the presence of dark matter adds another layer of complexity. Though we cannot directly observe dark matter, its gravitational effects on visible matter provide indirect evidence of its existence. Dark matter is believed to make up about 27% of the universe's mass-energy content, yet it remains invisible and undetectable by conventional telescopes. Its elusive nature makes it one of the most intriguing mysteries in modern astrophysics. Understanding dark matter is crucial for unlocking the secrets of galaxy formation and the overall structure of the universe. The possibility of other universes or a multiverse is another topic that continues to spark debate among scientists. While the idea of a multiverse remains speculative, it presents the tantalizing possibility that there are countless other universes beyond our own, each with its own set of physical laws and properties. This concept arises from certain interpretations of quantum mechanics and the theory of cosmic inflation. If these ideas are correct, our universe may be just one of many, existing alongside others in a vast, interconnected multiverse. However, proving the existence of other universes is an incredibly difficult task, as they would exist beyond our observable universe, and there would be no way to gather direct evidence of their existence. As we continue to push the boundaries of human knowledge and technological capabilities, it becomes clear that our understanding of the universe will continue to evolve. The discoveries made by the James Webb Space Telescope and other space-based observatories will undoubtedly lead to new insights and potentially challenge our current understanding of cosmology. However, it is also likely that many questions will remain unanswered, and some aspects of the universe will always remain a mystery. As we look to the future, the search for answers will continue, fueled by our unyielding curiosity and the desire to explore the unknown. In the coming decades, it is possible that new breakthroughs in technology, such as more advanced telescopes or even interstellar probes, could provide us with even deeper insights into the cosmos. The dream of reaching distant stars, exploring exoplanets, and understanding the true nature of dark matter and dark energy may one day become a reality. Until then, we must continue to rely on the tools and knowledge we have at our disposal, including the groundbreaking work being done by the James Webb Space Telescope. Ultimately, the exploration of the universe is not just about discovering new facts or solving scientific mysteries. It is also about expanding our perspective and understanding our place in the cosmos. The vastness of the universe is a humbling reminder of the fragility and fleeting nature of human existence. As we continue to look outward and explore the farthest reaches of space, we are reminded that the universe is far larger and more complex than we can fully comprehend, and our journey to understand it is just beginning.